Okay, hello everybody, what's going on? My name is Mohammed. Welcome to another video. In this video, I'm going to teach you how to solve for this integral. So we're given the integral of 1 minus sine 2x divided by 1 plus sine 2x all squared dx. Okay, so in order to solve for this question, we can benefit from the fact that sine 2x is twice sine x cosine x, and one can be rewritten as cosine squared plus sine squared or sine squared plus cosine squared. And we're going to do the same thing in the denominator. So that would make the numerator cosine squared minus 2 sine x cosine x plus sine squared, and that can be rewritten as cosine x minus sine x all squared. And we're going to do the same thing in the denominator, but we have a plus sign, so that would make it cosine plus sine all squared, and the term is also squared, so that's going to be to the power 4. So that's what we're going to do here. Okay, so the integral, okay, so first of all, let's rewrite, okay. So the integral becomes the 1 can be rewritten as cosine squared of x plus sine squared of x minus 2 sine x cosine x. Okay, and the denominator can be rewritten as cosine squared of x plus sine squared of x plus twice sine x cosine x, and that is raised to the power 2, and we have dx here. Now this can be simplified like this. Okay, we can notice, okay, that the numerator is nothing but cosine x minus sine x all squared, and the denominator is cosine x plus sine x all to the power 4 now dx. So now we have put the integral in a simplified form. Okay, now we can also benefit from the fact that now we can also, simplify it in a better way. We can take the numerator with a power of 2 and take one term of the denominator, which is of the same power 2, and then like split, okay, the denominator. So that's what we're gonna do here. Okay, so that would be equal to the integral of cosine x minus sine x divided by cosine x plus sine x, and we're gonna raise that to the power 2. Okay, so we have taken now a squared term of the denominator. So what is going to be left here is going to be dx divided by a cosine x plus sine x all raised to the power 2. Now we can go ahead and divide everything by the first term can be divided, the numerator and the denominator by a cosine. And also we're going to do the same thing with the second term, but instead of dividing by a cosine, we're going to divide by cosine squared. Okay, so that's what we're going to do here. Okay, so this is going to be equal to the integral of 1 minus tangent of x over 1 plus tangent of x, and that is all going to be raised to the power 2, of course. And then the other term, we're going to divide by cosine inside the squared term. So as if this is equivalent of dividing by cosine squared. So that would give us 1 plus tangent of x, of course, here, all raised to the power 2, but that is equivalent to dividing by cosine squared. So we're going to divide the numerator by cosine squared, so that would give us secant squared of x dx. Now we can go ahead and let the tangent of x equals u, and that would give us that secant squared of x dx is equal to du. So with that, we can rewrite the integral as 1 minus u over 1 plus u all raised to the power 2. And here we have du, of course, instead of secant squared dx, that can be replaced by du, and here 1 plus u all raised to the power 2. Now, notice that if we take the first term, which is 1 minus u over 1 plus u, and differentiate that, okay, so I'm going to differentiate that. Okay, so 1 plus u divided by, 1 minus u. 1 minus u divided by 1 plus u. Okay, I'm going to differentiate that. So that would give me, that would give me 1. This can be rewritten, by the way, as 1 plus u minus u. So it's 1 minus 2u over 1 plus u. So maybe that would make the differentiation easier. So this can be written as 1 minus twice u over 1 plus u, or we're going to differentiate that as well. If we differentiate that, that would give us the derivative of 1 is, of course, 0. The derivative of the second term is going to give us a squared term in the denominator. Okay, so 1 plus u, of course, squared. And 1 plus u multiplied by minus 2, and then plus 2. So that would leave us with minus 2 in the numerator. Okay? 1 plus u multiplied by minus 1, so that's minus 2, minus 2u, plus 2u, so minus 2u gets cancelled with plus 2u, and we're going to be left out with minus 2. Yes, exactly. Now, if we look at the other term here, it is basically exactly, but we're missing a factor of minus 2. So what we're going to do here, we're going to multiply by minus 2 and divide by minus 2, and that would solve the whole integral. So this is going to be equal to, now I is going to be equal to the integral of 1 minus u over 1 plus u all squared. And here we're going to multiply, of course, by minus 2 du and divide, and of course, 1 plus u all squared. Okay, but with this, we have multiplied the whole integral by minus 2. So, of course, we need to divide by minus 2. So, minus half here, so that the whole value of the integral does not change. So now we have a term which is raised to the power 2 and its derivative outside. So basically, a simple u substitution here would do the same, the whole thing here. Okay, so that would give us minus 1 divided by 6 of 1 minus u over 1 plus u raised to the power 3, of course, plus c. And then we can go ahead and replace u by tangent of x. So that would give us minus 1/6 of 1 minus tangent of x over 1 plus tangent of x. That's all going to be raised to the power 3 plus c, and that is exactly the answer to this integral. Well, if you like this video, hit like, and don't forget to subscribe to the channel and click the bell so you don't miss anything in the future. Thank you for watching, and see you in another video.